Hi everyone, my name is Krista Dietrich. Today I am going to be explaining the process of deriving the Michaelis-Menten equation today. Before I do that, I'm just going to define a few factors that are involved in this equation pretty heavily. So first of all, the Vmax can be described as the rate of reaction when the enzyme is saturated with substrate is the maximum rate of reaction. And then we also have Km in our equation as well, which is known as the Michaelis constant of the enzyme, an inverse measure of the affinity, which basically the Km is the concentration of substrate, which permits the enzyme to achieve half Vmax. Okay, and so now I'm going to move on into the deriving process of the equation. So the first four steps are already laid out for us, which I already drew up here. You can see 1, 2, 3, and 4. So just another quick summary. We do want to express VO in terms of measurable quantities like S and E total, so we can see how to test the mechanism by experiments in kinetics. So first we must replace ES in 2 with measurables. And then during the initial phase of the reaction, as long as the reaction velocity remains constant, the reaction is in a steady state, with ES being formed and consumed at the same rate. And during this phase, the rate of formation of ES equals its rate of consumption according to Model 1. So that's step 4 right there. And then also just remember that we're trying to solve for ES in terms of measurables so that we can replace it in 2. So first, for step 5, you collect the kinetic constants in 4. Let's see. And then here is step 5 right here. I don't know if you can see that very well. Kind of hard to see with the pen and paper. And then going on to step 6, you want to simplify 5, which is the first group of kinetic constants by defining them as Km. So we can simplify step 5 into Km right over here. And then in step 7, you can express the E in terms of ES and E total, which is right here, E total, ES. And then for step 8, you're going to substitute step 6 and 7 into 5. So let's see. Here's step 8. So you're going to take steps 6 and 7 and plug it into 5. And then there you have step 8 right here. So basically, once you get to that step, you're just going to be solving for step 8. So just use simple algebra. So first multiply both sides by ES, which can be seen in this column. I'll just kind of leave it out for you to look at because it gets tricky when I'm pointing. So first solve by multiplying both sides by ES. So you have ES on both sides, then collect the terms containing ES on the left. And then you factor ES from the left-hand terms. And then after that, you divide both sides by Km and S. And so for step 9, your answer should be ES equals E total times S divided by Km plus S. And then for step 10, you're going to substitute step 9 into step 2. So here's step 9 into 2. So you're going to substitute that back into the Km. And so let's see. So here's step 10 right here. Oh, let me get this a little straightened out. There's step 10. That's the equation right there. So it should be V0. Yeah, V0 equals Kcat times E total times S divided by Km plus S. And then we're moving on to our final step, which is recalling that 3, substitute Vmax into 10 for Kcat times E total. So our final here would be V0 equals Vmax times S divided by Km plus S. So here, I'll just put this up here so you can kind of see like my whole process. Okay, so basically this equation expresses the initial rate of reaction in terms of measurable quantity, the initial substrate concentration. The two kinetic parameters, which are Vmax and Km, will be different for every enzyme substrate pair. So equation 11, which is actually the Michaelis-Menten equation, describes the kinetic behavior of enzyme that acts according to the simple model, which is in 1, and equation 11 is of the form y equals ax plus bx. So this is the equation of rectangular hyperbola, just like the saturation equation for the binding of dioxygen to myoglobin. And then equation 11 means that for an enzyme acting according to the simple model, which is in 1, a plot of V0 versus S will be a rectangular hyperbola. When enzymes exhibit this kinetic behavior, unless we find other evidence to the contrary, we assume that they act according to Model 1 and call them Michaelis-Menten enzymes. All right, everyone, I hope that was a decent explanation of the deriving equation. If you have any questions, please just comment below on my video. Thank you.